Welcome to Physics World Online College, where we simplify physics and its concept to the barest minimum and to the clearest of understanding of the least among us. We encourage you to press the subscribe button, you share to other students, your friends, and also comment. We will respond to your comments from time to time. In our class of today, we will be considering equations of uniformly accelerated motion. Uniformly accelerated motion is the motion of a body along a straight line, or the motion of a body along a straight path. And that kind of motion is also called rectilinear motion, or simply linear motion. So we'll be looking at the equations we use to describe bodies that travels in rectilinear motion. We have three equations of motion for such body. Three equations of motion. We will need to learn how to derive them, to obtain them by derivation as far as this class is concerned. Actually, though we say three equations of motion, it could be four. In the course of our discussion, I will tell you about the fourth one. The fourth equation is also useful, where the other three equations might not come handy. So, let's begin. We say these equations define the motion of a body along a straight line or path, which are uniformly spaced. We will have to look at some parameters we will use to define this equation, about 5 of them. So let's look at them and know what they mean. So let's assume that A is acceleration of the body and the unit is meter per second square. U is initial velocity or speed of the body in meter per second. V is the final velocity also or speed in meter per second. We have T is the time taken to make the change or the motion in second. And then X is the displacement or distance in meter. This final velocity can also be regarded as maximum velocity or speed. So if in a question they say find the maximum velocity or speed, you know you are talking about the final velocity v in that motion. Now we will look at the equations and we'll consider them as cases. So let's take case 1. Case 1 as the derivation of the first equation of motion. This first equation of motion is obtained from the definition of acceleration, which is acceleration is the rate of change of velocity with time, or the time rate of change of velocity. Recall that acceleration is change in velocity over time taken for the change. Change in velocity means final velocity minus initial velocity. So we can write it as acceleration equals final velocity minus initial velocity all over what? Time. If we put the letters for each, we have A for acceleration, V for final velocity, minus U for initial velocity, all over what? Time, T. Now we'll cross multiply to make V the subject of formula. We cross multiply. After cross multiplying, I will advise you write V minus U first. You say V minus U is equals to A times T. You carry what? U to the other side, it becomes plus. We have V is equals to AT plus U. The preferred way of writing the first equation of motion is say or V is equals to U plus AT, and this is the first equation of motion. So if you are asked to state the first equation of motion, simply say V is equals to U plus AT. Let's take case 2 for the second equation of motion. Case 2, second equation of motion. The second equation of motion is obtained from the two definitions of average velocity or speed. Let's take them one after the other. Recall that average velocity or speed is equal to total displacement over total time. So the average velocity, we will use V bar to represent it, our total displacement x, our total time t. If we cross multiply, we have that S is equals to V bar times t. Let's call this equation A. Now, we recall the second definition for average velocity, which is also recall that average velocity or speed is equals to initial velocity plus final velocity all over what? 2. We put the letters. Average velocity is V bar, initial velocity is U, final velocity is V divided by 2. Let's call this equation B. So we will substitute equation B into equation A. So we say put equation B into equation A gives that S is equals to, in place of V bar, I will put U plus V over 2 multiplied by T. Let's call this equation C, and I will what? Star it or asterisk it for a reason. This equation C star, we will actually refer to it as the fourth equation once we have concluded the second and the third equations. So we'll continue with our derivation for the second equation of motion. Now recall equation 1, V is equals to U plus AT. So I will put it here. So we say but V is equals to U plus AT, which if you substitute, you will have that S is equals to U plus AT all over 2 multiplied by T. U plus U will be 2U. So we'll have S is equals to 2U plus AT over 2 times T. We can use t to open the bracket. We have that s is equals to 2ut plus at squared all over 2. We use these 2 to divide these two terms, which gives us s is equals to 2ut over 2 plus at squared over 2. These two will cancel 2. We're left with ut plus at squared over 2. The preferred way of writing this is given as s is equals to ut plus half at squared. So this is the second equation of what? Motion. So if you asked to state the second equation of motion, simply say s is equals to ut plus half at squared. Case 3. Case 3, which is the third equation of motion, will be derived. Third equation of motion. This third equation of motion, we will derive it from the first equation of motion by simply squaring it. So recall that V is equals to U plus AT. If I square this equation, take note, while squaring, I will square this. I will not square this alone. I will not square this alone. I have to group them, this one, and square them together. If you square them individually, you will be unable to simplify further. So you must take note of that point. So we say square both sides. So that will give us V square is equals to bracket U plus AT all square. So I have to what? Expand this side of the equation. This will give me V square is equals to U plus AT bracket, another U plus AT bracket close. I can now expand this bracket. So that will give me U times U is U square, U times AT is UAT, AT times U is also UAT, then AT times AT gives you A square T square. If you check, this UAT and UAT are similar. This is 1, this is 1. We bring them together, it becomes 2UAT. So I have V square is equals to U square plus 2UAT plus A square T square. These two terms, I will group them together and factorize out. You have to observe and take note of that factorization. So I said V square is equals to U square plus 2UAT plus A square T square. I'll group these two terms. I'm going to factorize 2A out of that group terms for a reason. So, and to do that, so I will say factorize 2A out. To do that, I'm going to apply what we call the law of transformation of equation. The law of transformation of equation. What does it say? It says that equation can neither be created nor destroyed, but can be transformed from one form to another. So I will use that law to transform this equation into what I desire. Let's look at it. If you check this, you will see that this first term has 2A. So it will be easier to factorize it out. So I have V squared is equals to U squared plus 2A, open bracket. Then this term has 2A. If I bring 2A out of it, I have UT left. Plus, this second term has A but does not have 2. So to mitigate that 2, I have to divide it by what? By 2. So that will give me what? A T squared divided by 2. You will see that if you open this bracket, you will get exactly what you have there, which is 2a times ut, 2uat, 2a times a, so a times a give you a square, and the t square, then these two will cancel these two at the bottom, giving you back what? A square t square. So that is true according to the law of transformation of equation. Also, this is done to achieve something which we have in mind. If you look at what we now have in the bracket, you will see it is similar to equation 2. So we can say that ut plus at squared over 2 is actually equal to what? S. So I'll copy and paste. Anywhere I have ut plus at squared over 2, I can put what? S in place of that. So I will now have v squared is equals to u squared plus 2as. This is the third equation of motion. Like I said, the fourth equation of motion is actually equation C star. So I'm going to quote it as the fourth equation of motion. So we have case 4, the fourth equation of motion. Recall that equation C star, we have S is equals to U plus V over 2 times T. This is the fourth equation of motion, but some will also write it as S equals half bracket U plus V over T. So that's the fourth equation. So we can conclude by saying you need to observe these 4 equations. There's something special about them and how they are applied and how they are used to solve problems. Let's observe. Observe that equation 1, V is equals to U plus AT. Equation 2, S is equals to UT plus half AT squared. Equation 3, V squared is equals to U squared plus 2AS. Equation 4, S is equals to half bracket U plus V times T. Now, something is special about each of them. Of the 5 parameters, 4 always appear in each equation and 1 is left out. For example, in equation 1, we have V, final velocity, U, initial velocity, A, acceleration, T, time. Something is not there, which is what? The distance or the displacement. So if you are looking for questions where displacement is given to you, you cannot find help in equation 1. Likewise, if you check equation 2, you will see we have displacement, we have initial velocity, we have time, we have acceleration, but there is no final velocity. So final velocity cannot be looked for using equation 2. Likewise, equation 3, if you check it very well, you will see it has final velocity, initial velocity, acceleration, displacement, but no time. So questions where you have to look for time or that time is given to you, please do not find or resort to help from equation what? 3. Lastly, from the fourth one, you have displacement, you have initial velocity, you have final velocity, you have time, but you do not have what? Acceleration A. So in questions where acceleration A is given to you or where you are looking for acceleration A, please, equation 4 will not be friendly to you. So these are the equations of motion. We have learned how to derive and obtain them. In the next class, I will discuss how the examples are solved using these equations. Remember to subscribe, remember to comment, remember to share. I believe you will learn even more in our subsequent class. Bye-bye.